Texture classification for fake Indian currency. Detection. 1p. Gayathri, 2p. Soniya, 3v. Yaminipriya, 4g. Srinivas, 5v. Ravindra. 1 UG student, 2 UG student, 3 UG student, 4 UG student, 5 Associate Professor V.S.M. College of Engineering, Ramchandrapuram. Abstract. In this paper, the automatic fake currency recognition system, AFCRS, is developed to identify the currency whether it is fraud or genuine. The present problems due to demonetization drags down the banking system and also in many areas. A new vision of curl neural network regarding of finding fake notes through their images is tested in this paper, which is relatively good than past image processing methods. This procedure depends upon intense study, which has seen enormous success in image segmentation charge in present times. This technique can help both human and electronics in finding a fake currency note in real time through an image of the same. The suggested method of AFCRS can also be situated as an implementation in the Android phone, which can be more useful for common people for finding the real or fake note. The precise of the suggested system can be increased by the original fake notes, whereas the suggested system has the images from children's bank churan label. Introduction. Automatic identification of fake note is very crucial in some areas like banking, jewelry shops nowadays. This method is used to find whether the note is genuine or duplicate, by the automated system, which is by convolution neural network, in intense learning. Intense learning shines in the task of identification and dividing the images over a huge data collection. The demonetization drive is a tramp to eradicate manipulation and black currency notes, but it badly fails to find the problems of counterfeit currency. A intense neural network is a mathematical model that works in a close trend to the neurons in our brain. Each neuron takes the data, undergo some functioning and give its result to the following neuron, that is to its hidden layer. Recognizing a duplicate note by mere visual inspection is quite complex task. Most of the common people are not conscious of the safety features present in original currency notes and thus residue at risk. To research method, it is feasible for everyone to stamp fake notes with the help of computer and different scanning techniques. After demonetization, this problem becomes more such that it can be identified through many machines by various techniques listed below. 10,7,1. A techniques. The sheet and based currency identification system used squash grayscale and implementation for Sri Lankan notes. 9, handover by D.A.K.S. Gunaratna, H.L. and N.D. Kodikara. Premaratna developed a method of image data collection pre-processing through grayscale conversion, the image subdivision, edge detection, and PCA methods in the year 2008. The sheet Bangladeshi currency note identification by neural network with center line uniform marks. 14, invented by N. Jahangir, neural network identification scheme by backpropagation algorithm using multi-layer perceptron in the year 2007 was introduced by A.R. Chaudhary. The paper Multiple kinds of paper currency identification using neural network and application for euro currency 6 proposed by F. Takeda. T. Nishkage introduced the increase neurorecognition design using sensors in the year 2000. The review presented by A. Frosny, M. Gori and P. Priami in the year 1996 through a paper A neural network model for paper identity and verification 11 classifies and verifies through a model called multi-layered perceptron. The paper, which is presented by F. Takeda, S. Omedu high-speed identification by neural networks, system, 5 in the year 1995 tells that how the identification is done by a normal method of neural system that is among only one unseen layer, input layer, and output layer. The review held by M. Fukumi, N. Akamesu in the year 1996 by a paper The method to design a neural system pattern identifies the system using a genetic algorithm with partial fitness and acceptance change 15 uses the transmitted algorithm for identification system. These are few routine related to detecting and identifying in the fake currency paper. B. Software models for paper currency. The method, which is presented by Mirza and Nanda in the year 2012, tells that they take out 3 feature, identification mask, security band, and watermark, using edge-based segmentation with the help of Sobel operator 8. In the year 2012, Sharma.jet.al proposed an algorithm based on LBP, local binary patterns, which produced good performance for image with low noise with 99% perfectly too. Mobile currency identification method using SIP to identify partial images was proposed by Pagios.et.al in the year 2012 states that the design is estimated using finite sample set with different state which are folded, imperfectly. They used KNN algorithm which has an accuracy 75% for the first method and 93% for the second method. For Sargano.et.al initiate an algorithm feed-forward backpropagation neural network used for classification which consume less time when differentiate to other algorithms in the year 2013. 3. In the year 2014 Da Costa invented a banknote identification system to identify set of banknotes in a contrasting view and scales. He used feature detection, description, and matching which are used to increase the belief in identifying results. But the suggested method is not acceptable for mobile phone because of high computation power. Whereas the outputs are vigorous to handle the folded and creased notes. 13. Considering the Ray's composition survey, we should consider an algorithm which grasps less time, keeps high precision, which can be adaptable for Android phones and can also work with large data sets. Regarding to my observation, CNN algorithm is the one which convinces all the circumstances by omitting the restrictions which are in the above similar methods and papers. The advantage of CNN over the image processing method is that, CNN are exclusive type of neural network for processing input data that has an fundamental grid-like topology. Generally, the data given to a CNN will have regular shape to it such that neighboring are correlated. A CNN strive to identify the most applicable patterns that help to find how to complete the given task. However, the drawback of image processing is high in cost. CCD that is used for digital image processing has some drawbacks like memory card problems, higher cost, and battery usage. 3. Theory and experimentation. In order to apply the proposed solution for finding fake notes, we reproduce the functions using CNN with the help of Python language. A proposed solution. We will be constructing a convolution neural network according to suggested algorithm which will be instruct on a given duplicate and real currency set, and later be able to forecast whether the currency is original or fake. In this of course we will be decoding an image classification problem, where our aim will be to tell which category the input image belongs to. We are going in such a way to reach it is by teaching an unnatural neural network on image data set of currency and make the NN to forecast which class the image related to, when it sees an image having duplicate note or original note the next time. In CNN the feature extraction and classification takes place automatically within a single framework. They have many advantages when compared to many other image processing methods. B. Architecture of CNN. For our project we make use of Python libraries like Theano and TensorFlow for applying and teaching the intense learning model. Many pre-trained models are available on the internet like Net, AlexNet, VGGNet, GoogleNet/Inception, and ResNet 12. About VGGNet, Figure 2, it is good because it contains of 16 layers with able to be learned parameters, that is weights and biases. The pooling layers learned to compress so many number of parameters in such very deep networks. In all convolution layer with the convolution stride set to 1 they use small 3*3 filters. At the end of the network they are 3 fully connected layers. The VGG networks use multiple 3*3 convolution layers to constitute complex attributes. Consequently, here we select VGG net architecture ILSVRC, ImageNet Large-Scale Visual Recognition Competition, 2014 competition. Figure 2, output screenshot of VGGNet model summary generated from the experimental setup. See dataset. We generated a dataset of paper currency notes. The dataset has been created for this particular resolution. The images have been gathered from different Google source. Dataset separated into 2 types. One is original, another one is fake notes, figure 3. In this AFCRS we have used 75% of the images for the purpose of training and rest 25% of the images are used for testing. Then we allow the trained images as input to output model and train the model. In generating the data set, we assumed that old currency notes which are used in advanced demonetization as fake currency, as they are legally banned, and if they are assumed as original currency, then it will become very hard while addressing the problems like in banking sectors. Figure 3, Fake and Original 2000 Rupee Note. D methodology. In coding role, use Keras deep learning library in Python to generate RCNN, convolutional neural network. In this install the TensorFlow is an open source software library. It is a representative math library and is also used for machine learning applications such as neural networks. Theano is Python library and improved for manipulating mathematical expressions. In Theano calculations are expressed using NumPy square syntax and compiled to run productive on either CPU or GPU architectures. Later installing the required libraries, we train output model as discussed above. Later training and testing the model, we adjust an epoch value which rise the accuracy of the AFCRS upon rise the value of epochs. 1. Pre-processing. The easy way to obtain the data without overfiltering and underfiltering is to pre-process the data set. The major aim supporting the data pre-processing is to add the value to the base value which is dataset generated. The major lead of data pre-processing is to obtain a better training set. For these causes, we use Keras library for pre-processing the images. The VGG16 model requires an input image shape of 64-64-3, where 3 indicates to the R, G, B, red, green, blue, requirements of colored image, and the image must be 64*64 pixel in size. We then apply the following 3 types. We require rescaling the image to construct the model data in a standard format so that the training is better, correct and faster. We have rescaling element in Keras. To apply this element, we need to buy libraries from Keras pre-processing as image data generator. If the rescaling element is none or 0, no rescaling is applied, or else we multiply the data by the value provided. This process is finished after applying all other transformations. For output model of Keras, we use a rescaling element as rescale equals 1/255 for training and testing data set. B. Image shearing. We need to shear the image to construct the training data better, exact. We also have shear range elements in Keras. This is to be better from the Keras pre-processing library. For output model of Keras, we use a shearing range. Shear range equals 0.2. Shear range is shear angle in counterclockwise direction in degrees. It is called shear intensity. See perspective transformations. The perspective transformations is applied on training data to zoom in the range. Zoom range equals 0.2 to gain the correct results by study in correct manner. The zoom ranges are float or lower, upper ranges for random zoom. This is finished by importing a library from Keras pre-processing. To training the CNN here, choose VGGNet for output model of Keras. We fine-tune the VGGNet 12, which is a pre-trained network. This speeds up the training process, since there are fewer layers to actually train. To train the neural network, it is important to start with a poor-performing neural network and bring up the neural network with more perfection. In words of loss roll, we want our loss roll to be too much bottom in the end of training. This specifies our neural network has high study rate and perfection. The problem of training the network is similar to generate the loss function with lower error rate. It is main and well organized to reduce the loss because, it turns out that loss is much easier function to improve. If there are so many algorithms that activation functions, we select ReLU, rectifier linear unit, as our activation function, and we can also select Atom as our improve function because, it improves neural networks by high-speed training and also computational step of ReLU is easy. To accept the given currency note as fake or real, we must see the perfect of the VGG16 model fine-tuned with the generated data set. It was suitable 55% on the corresponding test set, however our dataset was very little and limited to 200 images. If we expand our image dataset through real-world trials can make the model high perfectly trained, which may conclude our results beyond 80% perfect. This is quality sign for prediction of results. Despite the real score, the result must be assigned to overfitting on the dataset, as the training and test sets are very equal. Therefore, later pre-processing we must examine the loss and perfect trends of our model, AFCRS, by charging the batch. There are fundamentally two cases in deep studying regarding the loss and perfect values. 4. Acknowledgements. I would like to thank my joint authors, institute, and department for encouraging us throughout the project by holding project reviews and leading us through their precious imputations tirelessly. Figure 4. Screenshot of experimented model for recognizing fake currency. Recognition of currency. After having the knowledge of fitted model, we now require identifying the note which is shown in the sample figures, figure 4 and 5, these are the screenshots of our test method, AFCRS. From this survey, it is distinctly see the difference between the genuine and fake currency note. So, it is therefore preferable to situate the same in mobile as an application, which is a basic lead for the community. 6. Conclusion. In this research, we suggest a procedure which explains the viability of using CNN with the VGG16 architecture. As already the implemented data set was small and did not constitute the global scenario of duplicate currency data set, it was useful till the whole experiment. The procedure of finding fake note using this model is more accurate in time and cost. From this we can also convince that receiving the original and large data set, the model of AFCRS can be subservient and also provide correct outputs, which can be more useful for the people in identifying the money whether it is duplicate or original. Later analysis in this model can develop an Android app which makes the world more agreeable in finding fake notes. This process can also be differentiate with many architectures of CNN, which may have minor error rate than the existing model and can be merged by applying image pre-processing methods like edge detection to cut the unnecessary surroundings of the note out of an image, which results in effective outputs.